Alright, lesson 3-7, solving systems of equations using Cramer's rule. So by the time we're done with this section, we should be able to evaluate determinants and solve systems of linear equations using Cramer's rule. So to start with, we want to work with square matrices. So a square matrix is a matrix with the same number of columns as rows. So that's going to be our 2x2 matrices, or we could have a 3x3 or a 4x4. So it's a square matrix if the number of rows matches the number of columns. And then a determinant is a special number that can be calculated from a square matrix. So we can only find a determinant of a square matrix. This is going to be used to tell us useful things about a system of linear equations. Okay, so namely if it has a solution or if it's going to be infinite or no solution. Okay. And then we will also use this to help us find an inverse. And then our symbol for determinant is either going to be two vertical bars, so it looks like the absolute value symbol, or we're going to see the abbreviation DET and then whatever the matrix name is. Okay. So if you see either of these, it's asking us to find a determinant. So we're going to start with second order determinants first. So this is just a determinant of a 2x2 matrix. So again, we're going to see this. So we're asked to find the determinant of matrix A, or we're just going to see vertical bars around our matrices instead of the brackets. But the way we calculate the determinant is by taking what I'm going to call the forward diagonal. So A times D minus the backwards diagonal. So C times B. Okay, so we're going to subtract those two things. Whatever that simplifies to, that is the determinant. So if we do some practice, so again, it's going to be our forward diagonal. So we're going to take -3 times -5. And then we're going to subtract that from the backwards diagonal. So 2 times 4. So when we simplify, -3 times -5 is 15, and 2 times 4 is 8. 15 minus 8 gives us 7. So 7 is our determinant. Okay, so our next problem, again, forward diagonal, so 4 times 2 gives us 8. And backwards, 4 times 2 again is also 8, so that gives us 0. So 0 is the determinant. And the last one, so again, 8 times 3 is going to be 24 minus 2 times 7, so 14, so our determinant is 10. So now again, these numbers tell us about the inverse of these matrices. So if we get 0, so if this one happens, no inverse exists. If we do get a number, this means that we can find the inverse. Okay, so any number, and these can be positive numbers or negative numbers. Okay, so if we get 0, we won't be able to find the inverse, which means that we are either dealing with a no solution or infinitely many solution. Or if we do find a number, then we can find the inverse, and it's going to have a single solution answer. And we're going to talk about inverses in the next section.